So there's two important things about any place value based system. So we're doing base 4. What's one of the important things about using a base 4 number system?
4 digits to work with.
4 digits to work with. Okay, so let's write that down. I have the digits 0, 1, 2, and 3. So like in base 10, we have an actual digit for 4. We can't use that here. That doesn't apply. What's the other important thing about working in this number system?
Grouping by 4.
Grouping by 4. Yeah, we just got to think groups of 4. With that, in a little practice, we can do anything. Just like you guys can do amazing stuff with your base 10 number system. So on that second page, second box, last problem, they are showing counting numerals in base 4, and they give 3, 3, 3 in base 4. And they ask us to state, well, you know, what was right before this, and what number comes right after this. And there's a homework problem you may or may not have done yet that picks different number bases, and you have to say what's the preceding number, what's the following number. So the one before, I think, is the easier one here, because it's whatever right is before the 3 1s, which would be 2 1s. So 3, 3, 2 in base 4 has to be right before it. Now, I'm just going to omit the subscript little 4, FOUR there for now. The other thing to consider is the 3 in this number system behaves like a 9 in our number system. So if I'm in a base 4 world and I try to add 3 and 1, what do I write down as the sum? 1, 0, right? Yeah, so call it 1, 0 or 1t. It says you have one group of 4 and no 1s is what that says. So when I try to increase this by 1, that's going to jump a digit over to that column. But then what happens when I add a 1 and a 3 there? That's going to jump us into the next column, which is going to give us, I think, 1 with 3 zeros. So, big question. If that's true, what place value is that 1 in right now?
6. Well, it would be the 4 and the 4.
Almost. So these are our 1s, right?
Yeah,
and then we have our 4s. And then our 4 squared, so this will be my 4 cubes. Anyone know what 4 cubed is? 64. So this should mean I have 164 right there. And no 16s, no 4s, no 1s. So in Fourian, they would say 1, 0, 0, 0 to mean what we would call 64 things. I just want to double check that's correct by picking apart that numeral right there. So what does that mean? So 3, 3, 3 in base 4. I have to name each place value. So starting on the left here, that one's easy. I have 3 1s. The next place means I have what? 3 4s. So and I have 3 4s. And then this last one means I have 3 what?
16.
3 16s. Yeah, 3 16s. So let's see. Adding that up, 3 16s is 48. And 3 4s is 12, and 3 1s is 3. So that's 40, 50, 60, 63, I think is what that adds up to. Does that match with what we thought the next numeral was? Yeah, we thought it was 164. So just double checking that that's the case. So another challenging thing, so once you start working in a number system, it's really best to just kind of stay in there. It's like, it's a pain in the butt to convert from American measurements to metric measurements and back. But if you just measure in meters and centimeters, it's super easy, right? The conversion is the hard part. Unfortunately, because you guys are going to be teachers, I'm training you as thoroughly as possible, so we're going to do conversions between each number system. So we can convert from any base to base 10 by just naming the place values and expanding it, right? Remember, this is called expanded form here. And if I know I'm grouping by a certain amount, I can name each place value, and then I can expand it and convert to base 10. To convert the other way from base 10 into some other base, then it's all about regrouping by that base. And what operation in mathematics is the master of regrouping? Multiplication and division. In this case, division is the one I want. I want to start looking for groups of 4 in a particular number. So let's take, for example, 75 in base 10. I want to convert that to some number in base 4, or some numeral in base 4. And I'm just going to repeat 2 ways I did it yesterday. One, by the way, whenever I say yesterday, that's the last time we met, and tomorrow is generally the next time we meet. So the other day, we did this in 2 different ways. One was by thinking about the place values. The other was by repeated division. Does anybody have a request for how to start this one? Repeated division or thinking about place values?
Could you do the repeated division? I wanted to try to learn that.
Yeah, it's a really cool method. So we'll do it. We'll start with that one, then we'll do the other method. So the way it works is you just think, okay, I need to group by 4. Let's take 4 into 75. And when I do it this way, I use what's called short division, not long division. In long division, you write a whole bunch of subtractions underneath. In short division, you do it all in your head, which makes it a little more challenging. 4 goes into 7 once with, 3 left over? And then 4 goes into 35 8 times with a remainder of 2. Does that sound right?
No, remainder 3.
Remainder 3, yes, you are correct. Thank you. Good job. Remainder 3. And then I just keep repeating this. So now I switch off and I take these 18 groups of 4 and I break those into groups of 4 also. So 4 goes into 18, 4 but not 5 times, with a remainder of 2. And I keep going up the ladder here until I get a 0 at the top. So 4 goes into 4, 1 time, with a remainder of 0. That's important. And then finally, I try to take 4 into 1 because I need to see it goes in 0 times and that the remainder is 1. So according to this method, 75 things in our number system, 7 10s and 5 1s, is 1 0 2 3 in base 4. We'll expand that to double check in just a second. So that's my belief if I did this right. If I didn't mess up any remainders or subtractions. So just to check that by expanding it, let's do that down here. That is 164 and 0 16s and 2 4s and 3 1s. So what do I get there? I get 64 plus 8 plus 3, which is, let's see, 72 plus 3 is 75. I think that does work, doesn't it? That's up to 75 when I expanded it. And again, the way it works is if we just focus on what that 18 means there, I divided 4 into 17, so 75, excuse me. What does that mean? 4 goes into 75. Division asks the question, how many groups of 4 are in 75? And division gives the response back, there's 18 groups of 4. With 3 left over. And so the key here is, again, what does this 18 mean? It's groups of 4. So I just took 75 ones, and now I have a whole bunch of blocks of 4. So back to that toy I was playing with before. Where'd you go? I have a whole bunch of these guys. How many of them do I have? 18 of them with 3 left over. That's one way to talk about what 75 is. And so then the next stage, we start dividing by 4 again. Then we start looking for 4s in these kinds of objects. And every time we find one, we make a note of it. So I can, let's see which one's regroup, this one. So when I find a group of 4, I throw them together. Now I found a 16. So when I jump up to that next level of division, I'm now talking about how many 16s I found. So then move over to the remainders. If these are 18 or groups of 4, then the 3 left over, those must be the 1s, right? Those are 18 groups of 4. Is 18 a multiple of 4? No, there's some left over. So these 2s right here, those are 2 leftover groups of 4 that didn't regroup into 16s. Right? So each remainder is significant because it tells me what wasn't a group of 4 when I started packaging stuff up into packages of 4 and 4 4s and 4 4 4s and so on. Does that kind of help with how that works? Yeah. So that's one way to do it. The other way to do it is to just think, well, what's the biggest place value I need here? So the alternate is to start naming off base 4 places. So we always have our, oops, that's not a pen. We always have our 1s, black pen. And then the next place is always whatever base we're in, our 4s. Next base is my 4 squares, that's 16. Next base is my 4 cubes, that's 64s. And I usually go a little farther than I think I need to just double check. If I take 4 times 64, what does that give me? 256, I think. Somebody check me on that? Maybe a calculator nearby.
Yeah, that's right.
Okay, so 256 is the next place. So then I look at the number in question, my 75 in base 10, and I say, well, what's the biggest place value I need? And I say, okay, I need that place. This one's not necessary for me. And I say, okay, how many 64s are in 75? There's 1 in there. And if I subtract, what do I get? 11 left behind? Isn't that right? Okay, so then I move on to my next place. So I have 11. Now these are 11 1s, by the way. I found 164 in there. So here, it's not the remainder that's the important thing, really. It's the quotient. Quotient's the result of division. So then I take my 11 and I say, okay, are there any groups of 16 in 11? There are none. And so my remainder is still 11. So then I take next place value is 4s. Are there any 4s in 11? And I can say, yeah, there's 2 of them, right? 8, subtract, and I get a 3. And since the next place value is 1s, I got 3 1s. So it looks like my answer is 1, 0, 2, 3 in base 4. Which is kind of how you count back change if you're a cashier. You give the biggest bills or the biggest coins first, and you work your way down to the smallest bills, counting up to the large amount that you want. Okay, so again, we just discovered that 1, 0, 2, 3 in base 4 is the same as 75 grouped by 10. All right, fun and excitement of number systems. But it's amazing what we take for granted. We know so much and we do it so easily, and then there's all these kids we have to work with and it's so brand new to them. And the places they get stuck and try to understand, and the misconceptions we have that we carry along for such a long time. So we just got to really pick it apart to make sure we get it. Okay, what's next? Let's see, activities. I think you have most of the information or all the information you need to kick butt on activity 4. I'll leave some time at the end of class to come back to that. All right. What's in the loop? So let's see, we're skipping activity 2, right? We're doing activities 1, 3, 4, and 5 in this unit. So what's in the loop is we're going to play with that right now. To do that, we need the attribute pieces. And so, I was supposed to make color printouts for you guys and I forgot. Darn it. All right, you're gonna have to label some black and white printouts. My apologies. I don't have a color printer in this building. Let's see. I started trying to build them in Google. Let's print that, see what it's like. Print. Those of you who have the workbook, these are in your workbook in the back. There's a set of these. Okay, who has a workbook here? We have one workbook, and Kristen has one, but she's not here, so we need 1, 2, 3, 4, and I want one too. So let's go 5 copies. And then the other thing we need are the labels, which we can wing that. So attribute pieces are just toys that have obvious ways to categorize them. Like here, I can categorize by type of shape. I have triangles, squares, circles, and these are parallelograms. And then either those shapes are big or they're small. And then either they're blue, yellow, green, or red. So I have 3 different attributes here. And let's see, there's 4 shapes, 4 colors, and 2 sizes. 4 times 4 is 16, times 2 is 32. So there's 32 possible shapes in this particular set of attribute blocks. So since you guys have got black and white copies here, you'll have to label colors on there. So I'd recommend just giving them a letter. Did you find your pieces in there? Yeah. They should be on 2 different cards, right? Yeah, okay. So some of the things we're just trying to get out of this is just playing with sets, Venn diagrams. We're going to play with ideas of cardinality, unions, and intersections, which we talked about a little bit before. So I'm just going to make a note of the main ideas. So we're playing with sets. To play with sets, we have to mess with attributes. Size of a set is called the cardinality. We're going to mess around with Venn diagrams, unions, and intersections. So just a couple of notes on each of these main ideas here. Set is like the most primitive idea in mathematics. And when you get to really primitive ideas, it's hard to describe them. So just help me out here. What do you think it means to be a set?
Pieces of something that are similar.
Pieces of something that are similar. What do you mean by pieces?
Individual objects.
What do you mean by individual objects? Right, so you know what I mean? You just gotta ultimately you gotta show somebody, well, these are individual objects, right? We are individual objects. Somebody might say a set is a group of things. Okay, what's a group? A group is a collection. What's a collection? A collection's a set, right? So all the words we use, the keywords define them, but ultimately they loop back around to the same idea. And you just gotta show somebody. You just gotta get used to what it really means. So the best I can do for now, a set is a group of things. It's up to you to understand what things means. It's up to you to understand what group means. But I can sit down and show you, right? Attributes. Attributes are characteristics. They're qualities. What's a quality? That's an attribute. It's like being red, or being big, or being a triangle versus a square, right? So something that defines an object. Cardinality. Cardinality is the first fancy word for count. How many? Venn diagram, I'm just going to show you that. We've seen them before. I'm not really going to define it right now. It's a picture. Does anybody remember the key word when we talked about the idea of a union the other day? Or, right. And is it the inclusive or the exclusive or? It is the inclusive or, which we also interpret in like regular language as and or. You can have cake and or ice cream. One's okay, the other's okay, but both is fine too. Intersection is associated with and. So those are the ideas we're going to play with in activities 4 and 5. So in activity 4, it said to play this game, we need attribute paces, we need labeling cards, and a loop of string. So we're going to not worry about the loop of string or the labeling cards, because we're just going to make up some labels. So what I want to do is just, I'm going to pick a set. I'm going to pick a set called red things. Right, and then we look at the toys we have to play with, and my toys are over here. And so as far as red things go, I've got a big red triangle and a big red square and a big red circle and a big red parallelogram, or you could call it a diamond maybe, or a kite. And then I have a small red triangle and a small red square and a small red circle and a small red kite. Okay. So this is an activity we play with like really young kids, just trying to get used to grouping stuff together. And then we count them, right? So in the set that's red things, I can count 1, 2, 3, 4, 5, 6, 7, 8. So I mentioned before, activity 4 is like pretty super easy. It's just getting used to some new terminology. 5 is the way more exciting one. Okay. So I'm just going to look at a couple more ideas in activity 4, and then we'll jump on to activity 5. Oh, complement. I forgot to talk about complement. Let's go back a step. I can fit that here. Blue. Now notice it is a complement, not a complement. Right? So the difference is it's not my you look very nice today. In this case, complement is the opposite of. Right now it's only talking about it. So remember we talked about negating statements back when we did the logic stuff a week or so ago? The complement is negating that. So if I have the set of red things, okay, in that set, I have the large red triangle and the small red triangle, and the large red square and the small red square, and the large red circle and the small red circle, and the large red kite and the small red kite. The complement of the red things when we talk about complements with sets, we put a bar over them. That means everything that's not a red thing. So the complement of the red things is everything else that's not red. So just a note on counting stuff, if there's 8 things in the red set, and I know there's 32 things total, can we then figure out how many should be in the not red set? Right, we would just subtract that, so it should be 32 minus 8. On a good day, that's 24. Okay, so there should be 24 things in this set. So let's just look back and see if we can confirm that. So I'm going to grab a new page. Screen clip. Oh, wrong picture. Escape. There you are. Screenshots. Come on. All right. So we want everything that's not a red thing. So you're out, 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 and you're out. So that leaves these other columns of stuff. So let's see, how many is in each column here? There's 4 of them. And how many columns are there? 4 times 6. Yeah, there's definitely 24 things in the not red set. Okay. So activity 4 is just playing around with some basic concepts of set, mainly the idea of a complement. the idea of counting, which is cardinality of a set, and just grouping stuff. So I'm going to skip over to activity 5. That one is the fun one. And this one, you're going to have to do some drawing because we don't have yarn and colored pieces. So here, we still have the attribute places. The label cards are just names for possible qualities or groups of qualities, and we'll just make those up in a minute. So here they're saying, let's get warmed up by talking about the set of large things and the set of red things. So on a piece of paper, give yourself plenty of room on that piece of paper. We're going to draw a similar diagram to this one right now. So this is a Venn diagram. So a Venn diagram usually has a big rectangle to start with. The big rectangle is known as what's called the universe. Sometimes they just call it U. One thing we want to be careful about when playing with sets and set notations, there's a difference between the U symbol with the hook and the U symbol without. So this is the letter U, which means my universe, everything I have to work with at this moment. The symbol without the hook on it, that means U for union. And they're two totally different things, so be careful about that. It once caused me great grief when I was in college because I was too little. They're both U's, but no, they're not. One is a hook. That means the universe. So for us, the universe at this point in time is this set of toys here. So that's our universe. And then in our universe, we're going to break it up by having a set that we're going to call, I'm just going to call it L for large. And I have another set that I'm going to call R for red. And anytime you pick two sets in a universe, you break that universe up into possibly 4 pieces. Okay? So imagine these are fences on somebody's land. We have this big open area outside the figure 8, and then inside we have 1, 2, 3 disjoint sections, okay, that we can put different stuff in. And so what we want to do right now is identify which shapes go in each of these areas. Now on the worksheet, they labeled those areas. How did they do that? They called them A, B, C, and D. So A, B, C, and D. So we got to figure out which shapes go where. Now before we do that, I just want to play a little bit more here. If I take set L and then I intersect it, that's the upside down U symbol, with set R, that identifies one of these regions, either A, B, C, or D, or a combination of those letters. Which one do you think that is? That is B, correct. Yeah. So this region right here that they called B, I could also call L intersect R. Now I could also take set L and make a union with set R. So that means things that are large or red. Which letter or collection of letters is L union R, do you think? A, B, and C. It's the whole figure 8. Yeah, it turns out it's this whole figure 8 is this L union R. Okay? Because check it out, right? It's large or red. And if I look back at my shapes here, this shape right here is large, so it gets to be in the union. It also happens to be red, so it's another reason it gets to be in that union there, so it's okay. Right? Does this guy over here get to be in the large or red? It's red, so it gets to be in, but it's not large. Okay? Does this guy over here get to be in the setup that's large or red? It's large, it's good enough. So as long as it meets one condition, the other condition, but it could meet both conditions, that's okay. Now, if we had a set of plastic ones of these, we could lay them down in our figure where they go. So instead, we're going to abstract it a little more because we don't have a set of plastic ones here. What I'd like you to do is figure out how many of these shapes are just in section A? How many of them are just in section B? How many of them are just in section D? And how many of them are just in section D? So play around looking at your shapes. I'll put my colored version up here. If you have the black and white picture here, then I'd recommend like putting B's in each of these guys to denote that they're blue, and yellow Y's in each of those guys to denote they're yellow, just to help keep track of them. It's not a bad idea. All right, so we're gonna pause here while you all do that. I'm gonna do it too, and we'll regroup in just a moment and see if we agree. Feel free to check with your neighbor. So these guys are cool. Well, I should have brought my crayons. We could just color them.
Get it done, and that project will be complete. Really? Ordering, an ordering student, is that what you call it? Honor student. And a worker. And my son Stephen worked for Bruce when he was here, supporting business learning stuff. So, yeah.
I'd say classrooms, we've seen a lot of Zoom support stuff. That's where I started.
Cool. Good for you, nice to meet you. All right. We'll
All
see
right,
you.
see you later.
Okay.
Bye.
Okay, anybody think they got some numbers? Hey, what's up?
Sorry, is everything working okay for you? I haven't caught you and
Yes.
talked to you. I didn't
Yeah.
know you had a class. I just saw you sitting there. I thought you were just sitting there drawing.
No, yeah, we're all playing with it. Yeah, we had lost power and then the starboard went out and it was all this
It's all
little
back up.
trivial things wrong with that.
Okay, great. Thanks.
Yeah, all right, what you got? You got something? Okay. And what about the outside region? That's yours. Good. Good luck.
I didn't really see that. So
Okay.
you guys said there are 16 large ones, 4 large ones.
Large blue red. Oh,
How's it going? Getting there?
this is large or red,
Correct.
large and.
All right, so everybody's got something written down. Let's see if we can piece it apart. So again, if with kids, I would have these toys in front of them and they would just set them down. And it's pretty easy that way. Since we're trying to abstractly do it mentally, it's way harder. So we're doing it at a whole different level. So my belief is that this is the distribution of shapes. So let's pick it apart and see if I'm right. And if so, why? If not, why? So let's get some red to mark this up. So I started in the middle here, and I'm just going to describe that group right there. I believe those are pieces that are large and red. Okay, so that's the intersection. Intersection means large and red, and I could pretty much look over here and say, well, yeah, there's 1, 2, 3, 4 large red shapes. I got that part down. Now, the trick is then what to do from there. And for me, I said, all right, let's focus on the large shapes. Now, there's 2 ways to think about it. One way is to say, well, I know there are 16 large shapes, but I've already accounted for 4 of them. So that means there should be 12 other large shapes that don't get to be there. So let's figure that out. So there's this crescent moon shaped right here, right there. What does one have to be to get into that club? Do you have to be large to be in that club? Definitely have to be large. Can you be red in that club? Doesn't matter? It
Not just for that
does.
crescent shape.
Yeah, to be red, you got to be over here in this circle, right? So if we're outside of the red circle, you cannot be red. So to be in this club right here, that crescent moon shape, you have to be large and not red. So thinking about it that way, looking back at my pieces, here's my large shapes. I'm pretty sure this group right here are the ones that are large and not red. You with me? Altogether, they make my 16 large ones. So usually when I'm trying to troubleshoot situations like this, if I know I have 16 larges, I don't write the 16 right there. I usually make a little note next to my L for large and say, hey, there's 16 guys total in that circle. Make sure you distribute them right. So I usually just kind of pencil in some notes for myself. How many red shapes are there altogether? There's 8, so like often on my paper I'll make a note, there's 8 reds. I know there's 4 in the intersection. There should be 4 in the red that aren't in the intersection. So let's see if we can nail that. So, oops, that's gray, oh well. So I have this crescent moon shape over there. So think for a minute about what it means to be in that particular club, in that set. What's one characteristic the things in that crescent moon section have to have?
Red.
They gotta be red, right? So those guys are for sure red. Okay. Can they be large? No, the large shapes have to be over here in this other circle. So that must mean they have to be what?
Small.
Not large or small. So sometimes not an attribute has a name. In this case, not large is small. If we had medium pieces, then we'd be in trouble, right? But here I can just say it's red and small. Looking back at my set of pieces, are there really 4 shapes that are red and small? And yeah, there are. So that kind of works out. So there's a couple of different ways I can think about it. Okay, looking at the Venn diagram. So the purpose of using Venn diagrams is like troubleshooting, how to organize stuff. And then, well, I have 12 there, 4 there, and 4 there. What does that add up to? 20? I know my universe has to have what? 32. So that means there's got to be 12 outside of here. Let's see if we can give a name for those 12 things. So what can you tell me? What has to be true for something to live outside in this region out here, outside of the figure 8? Definitely not red. Okay. So not red. And not large, so we'll call that, in this case, we can get away with calling it small. So you have to be not red and you have to be small. All right. That totally looks like graffiti. So let's go back here. Okay. So the not reds, well, and small. Okay, so that's, I have to be in this group and not red. So that's either this column, and this column. So 4 times 3 is 12. Yeah, it works out. There happen to be 12 pieces that are small and not red. All right. Okay, so let's try to answer some questions on our activity here. Why must the loops be overlapped in order to place the attribute pieces correctly? Well, if they didn't overlap, I'd have a problem. Like, suppose what they're saying is, suppose you redraw the picture to look like this. Those are my large, those are my reds. So that big red square, where does it go? Does it go here or does it go there? It's gonna go in both, right? So that's why when we initially talk about sets, they gotta overlap in case there's something in the middle, and there is in this case. Okay. Let's see, complete the sentence describing the attribute pieces that are in the shaded region. So how would we describe again the pieces in the shaded region here?
The pieces that are large or red.
They are large or red, correct, yep. And that's it, just large or red. Okay, so those are not too bad to answer. So what we're going to do is we're going to take it a little farther down to the next page. You won't have any problem with these questions, I'm sure. I'm going to let you puzzle over number 7 over the weekend. What they're saying here is they put a few shapes in each of these regions, and you're supposed to guess at what those regions should be labeled as. Okay, so we'll come back to that. And the abbreviations would be large red. R stands for rhombus. That's another name for that diamond type piece. It's a rhombus. Over here, this would be the large blue square, the large blue triangle, the small blue circle. Okay, so they're abbreviating the names of each of those suckers. So you're going to try and come up with what you should call each of these sets so that that makes sense that that's in the intersection, that makes sense that that's outside. So think about that. We'll come back to that next time we meet. Today's already Wednesday, right? So next Monday. So what we're going to do now is we're going to pick a partner or two, and we're going to come up with a label name for one set and another label name for the other set, and then see if we can identify which pieces go in each of these 4 disjoint regions here. Okay, so disjoint means non-overlapping. So find a partner.